Alright, so exercise 9 here is kind of a doozy in that it looks pretty short in here, but actually it's asking us to write 5 different functions here that all iterate through a list and kind of do a specific thing. So even though it looks like a short question at first, I'm glad I did not try to include it in the last video because it's going to actually take a little bit of work. So it's asking us to re-implement these functions that we use on a list, these list methods, re-implement them in a way that doesn't actually utilize those functions. So we can do that nice and easily. We're going to need to define count. We're going to need to define in, so we'll define it as is in. We're going to need to define reverse, so we will define reverse. We're going to need to define index, so let's do that, index, and we're going to need to define insert. So we'll do precisely that. So we're going to want to iterate through the list in each of these functions and do whatever the function that, whatever the method that we're trying to re-implement would do. So what does count do? Well, count iterates through a list and returns a count of how many times a certain object appears in a list. So our count is going to need to take two parameters. It's going to need to take a list, so we can call it a list. Sometimes you'll see people commonly use LST for a list argument in Python, but we'll stick with a list, and then we'll need to look for a certain element. So we need a list and an element, and we'll go through and count that element. So because we're counting, we know that we're going to be using an accumulator pattern. So we want to initialize an accumulator variable, and we want to iterate through the list. So for item in a list, we need to see, does this item match the element that I'm looking for? If it does, iterate our count, and then return count. Nice and easy. So that's our first one, already finished. Is in is similarly very, very easy. So again, is in is going to take a list, and it's going to take an element. And we need to iterate through a list and see, are the elements, or do any of the elements in the list match the element we're searching for? So for item in a list, if item equals element, again, apologies for the dog, if item equals element, return true, because again, this is a Boolean function, because it's we know it is, because we have defined it as being a question. Is this in? So we know it needs to return Boolean. So for items in list, if item is equal to element, return true. Otherwise, if we get to the end of the list and we haven't found the item yet, we will want to return false. So there we go. Is in is the element in the list. If it is, return true. If it isn't, return false. Nice and easy. All right. So reverse is going to be a little bit more difficult, and there are a couple of different ways that we can do it. Right? We could use a range function. We could use a range inside of our for list where we start at the end of the list and iterate backwards through a range and append those values to a new list, which may be the simplest way to do it. We could also use a slice, the same way that we slice. I showed you guys last chapter to do a slice that returns a reversed word. I wonder if that works for lists. I don't know if it actually does. So let's try it real quick and see if it works. So we'll reverse a list, reversed equals empty. No, reverse equals. We would do this if we wanted to append it, but we don't want to append it. We just want to reverse the list with a slice if we're able to. So you'll remember that before I used this slice to try to reverse a list, to reverse a string in the last chapter. So we'll give it a shot. Can I use reversed as a variable because it's technically a method? I'll use new list instead because reversed is, I think, a built-in function. So we won't use that. I don't know. It's giving me weird coloring, syntax coloring on this highlighting. So I'm not going to use that. I'll use new list instead. And then I need to write these up really quick with pass statements so they don't block up the interpreter. And then we will try to reverse a list. So we will do my list equals 0, 1, 2, 3, 4. And we will then try to print the reverse of that. So print reverse my list and see what happens. We have an error on line 18. Oh, because I didn't actually. There we go. Forgot to put in those. Let's run this again. Yeah, so that slice trick from before still works, where we take the negative slice. So that's the easy way to do that. We won't, however, we won't do that. We will continue to do what I think the textbook probably wants us to do, which is to do a negative for loop. So for IDX for index in range length a list -1 -1 -1. So if you've forgotten how this works, it steps through the for loop backwards. So I'm telling it to initialize my variable, which in this case is index, at the length of a list -1, which will give me the index of the last item in the list, and then step through it by -1, or stop when I've hit -1. So stop after I've hit 0, and step through the list backwards. So decrement it by 1 every time. So start at if our list is 4 items long, it would be start at index 3, go until you hit index 0, and -1 every time through. So we would go, we would add to our new list, we would append whatever is at the current list index. So a list IDX will get us whatever the current value, essentially whatever the current value in the list we are working with is, and then append it to our new list, and then we would just return the new list at the end. So it's essentially an accumulator pattern, is essentially what this is, though we're using append rather than concatenating or adding, and we're doing it in reverse. So this should run functionally the same way. Should get me 43210, and it does. So good, we know that works. However, all of this is unnecessary because we can just do the same trick essentially with a slice. So I'm just going to leave it with the slice version because it's simpler, it's easier, it's smaller. We're going to do that. Okay. Index. So what does index do? Index iterates through a list, and if it finds the thing that we're searching for, it returns the index of that thing. So we will then obviously need to go through a list searching for an element. And we cannot do this. So we can't iterate through by item here because we need to be able to access the index of the item that we find. So we can't iterate through by item because we need to access the index. So when we need to access the index, instead of iterating through by item, we will iterate through by a range with IDX, or an index variable, being our variable that gets iterated on each time through the for loop. So you don't have to use IDX. Again, I've said this before, but I use it for simplicity's sake. You can use index, you can use just I, you can use whatever variable you want here, as long as you remember that the variable is the position or the index in the list. So you can use position, you can use index, you can use I, you can use IDX. I use IDX just because that's what I've always used, and it's you see this often used in convention in programming, so you'll see it pretty often. So for index in range, length of the list. So iterate through the list, and we've seen this a million times by now. So if this does not look familiar, it is doing the same thing that we've done with strings, with lists before, with all kinds of other stuff. That's all we're doing here. So for index in range in the range of the length of a list, go through the items. So if a list index, so that's the current item of the list, and if it equals the element that we're looking for, then we need to return the index. So simply return index. Now the issue here is that index technically returns an error if it does not find the element. So right now this will return none, which is fine. If we wanted to make it work like find does, we could have it return -1 outside of the for loop. Really, if we wanted to implement index, if we wanted to actually implement index here in the same way that index works, we would want to raise an error here of some sort to inform the user that this does not exist in the list. I'm not going to do that. I'll just leave it like this, and it will return none, essentially, if the value is not found. All right, and then insert. What does insert do? Insert takes a index, a position in the list, and it takes a value, and then it puts that value into the list. So again, we know that we can do this with slices, right? So let me get this going. I'm going to take in a list, I'm going to take a position, and I'm going to take an element. So I'm going to take a list, and at the position given, insert the element given. So I know that I can do this with slices, right? I can do a list, and then slice position, and set that equal to element. So that's simply very easily a version of this, right? So we could do that, but doing that in this case would actually cause a situation where this function now is not a pure function. This is actually modifying the list that we're taking in, which is the same way that insert works. Insert does modify the list that you give it. So this functionally recreates insert. If we wanted to make it so where this does not do that, what we could do is we could do new list equals a list like this in order to make a clone of the list, and then change new list like this and return new list. So we could do this. It does the same thing. We could also use an accumulator pattern, which would work functionally the same as our implementation of reverse that we did earlier. And I'm sure that is going to be the answer that they give in the answer section, so we can take a look at that in a second. Basically, all of these should now function correctly. So let's see if they have test cases in the answer section here that we can test for these. And they do. Let me see how they implemented reverse and insert, which are the two that we kind of did differently. So their count looks the same as ours. Their isIn function looks the same as ours. Their reverse function is different than ours, but also is the same as the version that we did write after we wrote our slice trick version. So that checks out. Index looks good. They're returning -1, which is, I don't believe, how index actually works, so isn't actually recreating index appropriately, but whatever, it's fine. And their insert is the accumulator pattern. So their insert is creating a new list and then iterating through the list by index. So iterating through the list that were given by index, and then if that index is equal to if I is equal to this index given, then append the object. But otherwise, if it isn't at that current index, then just append the entire list. So we can walk through this step by step. But for example, their insert that they give is their list is this list right here, and they want to insert cat at position 4. So if we go through with this as our example list, we can see how theirs works. So we take this list, and starting at the first item, we go through it. Does the index of 0 equal 4? No. Does index 1 equal 4? No. Does index 2 equal 4? No. Does index 3 equal 4? No. So for each of those, we would append them onto the new list. So is I, which is currently equal to 0, equal to index? No, it is not. So new list append the current variable. There we go. So 0 gets appended to new list. Does index 1 equal index 4? No. So 1 gets appended to the new list. Does index 2 equal 4? No, it gets appended to the new list. Does index 3 equal 4? No, it gets appended to the new list. Does index 4 equal 4? Yes. So append cat instead, and then append this item. So cat will appear between this 2 and this 2. So I'll just copy their test functions here into our code over here and run it, and we'll see what happens. Nope. We have an issue. Int is not iterable on line 3. What did we do wrong? Oh, I see. Their functions are written different than ours are. So we need to switch the parameters around. Their functions take the item first and then the list, whereas I wrote my functions so that it takes the list first and then the items. So a list position is 4, and the object is cat. There we go. All right, now it should work. Okay, so counting the list to see how many times 1 appears. 2 is correct. Is 4 in the list? It is, so true. Reverse the list, which we did. Find the index of 2. So the index of 2 is 3. So that checks out. And then insert cat at 4, which, oh, this is interesting. So we can't actually do that. Huh. What if I do this? There we go. I forgot that when you do this, essentially what you're doing... Sorry, let me rephrase. When I was doing my slice trick for item insertion here, what I was doing was inserting... when you get a string, it's going to insert the string as a list, essentially, as list items, meaning that it inserts the string individually, one piece at a time. So C, A, T, it inserts them individually, and so we got C, A, T. But we can get around that by casting the element as a list and inserting it. So in this case, we do that. It inserts the list version of it, so cat as the list. Now, does that work if I pass in a number? So if I pass in 3 to fit in between those two 2's, what happens? Okay, it does work. So that's a simple fix there for our version of insert. But again, if you don't want to use that version, you could have done their version of insert, which is kind of an accumulator pattern, or functionally you could just use the actual insert method, which is there and written already for us by super smart Python people. So we only have 2 more here, and then the weekly assignment. So I will take care of both of these in another video. So check out the next video, and we'll wrap up these last 2 exercises.